We're going to start with example 3. Okay, so example 3 is a different type of question, right? So it's asking, prove that 6 to the n minus 1 is divisible by 5 for all positive integers. Okay? And let's take a look at what does it mean for something to be divisible by 5, right? It means what? It's no remainder. So basically, what are some numbers that are divisible by 5? 5 is, 25 is, right? Right. So, 60 is. So basically, how would you write a general form of a number divisible by 5? It's 5n, right? So as long as it's 5 times something, that's divisible by 5. So that's what we need to show here. All right. And we're going to do it using mathematical induction, the 3 steps. So first, right, we need the anchor step. So for n equals 1, let's see if it works. 6 to the 1 minus 1, that equals 5. Is that divisible by 5? Yeah, okay, so that works. Okay, so now n equals k, right? Assume 6 to the k minus 1 is divisible by 5. What would that mean? That would imply that 6 to the k minus 1 is equal to 5 times some random number r. Right? Is that true? I don't want to use n because I feel like n is used everywhere. So let's just do 5r. Okay? Now, so this is the kth step. Okay, so now let's take a look at what n equals k plus 1 would look like. N equals k plus 1, okay, how would that look? Okay, so let's see. We're going to take this, okay, copy it here. Just copy it over. And what's 6? Let's just solve it for 6 to the k. Is that right? Okay, now, just for fun, I'm going to multiply both sides by 6. Why 6? Because it's the base of that exponential. Okay? So how much is that? 6 to the what? 6 to the 1 times 6 to the k is what? 6 to the k plus 1, right? So do you see how we get the k plus 1 step, right? So you need the n equals k plus 1. Well, you have 6 to the k. Somehow I need to end with a 6 to the k plus 1. The way in which I do that is I multiply both sides by 6. Okay? So 6 to the k plus 1 is equal to 30r plus 6. Okay? But how did my general form look like? 6 to the blah minus 1. Well, now I have 6 to the blah. How can I do minus 1? Just subtract 1. Why not? So now take a look at what happens. 6 to the k plus 1 minus 1 is equal to 30r plus 5, right? So let's factor that. Let's factor out a 5, and we get 6r plus 1. Now look, the k plus 1 step, is that divisible by 5? It's 5 times something, so it's divisible by 5. So there you go. I proved it. You see what happened? So let's review that one more time. It worked for when n equals 1. 6 to the 1 minus 1 was equal to 5. And then we said, assume that it's true for n equals k. For n equals k, 6 to the k minus 1, I'm just going to assume that it's divisible by 5. which means in math, if I want to say this is divisible by 5, I say this is equal to 5 times a number. Okay? So I'm assuming that 6 to the k minus 1 is divisible by 5. Now let's see if it's true for 6 to the k plus 1. Well, in order to do that, I just take this and I rewrite it as 6 to the k equals 5r plus 1. Multiply by 6. Subtract 1. So now I started with 6 to the k minus 1. Now I have the k plus 1 term. And look, that's also equal to 5 times something. So yes, this is true. So when n equals k, it was equal to 5 times something, divisible by 5. When n equals k plus 1, it's also equal to 5 times something, divisible by 5. Okay, so that's it. You're done. Here is when you can write QED. Okay? Huh? It is, which is what had to be proven. Like, this is how you end all mathematical proofs. It's quod erat demonstratum. Which is what had to be proven. Okay? All right, let's do one more. Okay, so prove that n is less than 2 to the n for all positive integers n. Okay, so any number is less than 2 to the power of that for all positive integers n. Okay, well, let's see if it's true. Okay, n equals 1. Does that work? Yeah. 1 is less than 2 to the 1. Yeah, it works. Okay, let's just try it again for good measure. You don't have to. For n equals 2, even there it works. Okay, all right, so what about n equals k? K is less than 2 to the k. Okay, if k is greater than 1, because this is saying for all positive integers n. So if k is greater than 1. Okay, you need to write that part because it's going to come in later.
Can it be k is greater than or equal to 1? Because 1 would work too.
I'll tell you why you need, no, greater, keep it greater because this is less than. Keep it the same. Okay, now, okay, what do we need to show here? Now we need the n equals k plus 1, right? Okay, so what do we need to show? We basically need to show that for k plus 1, it's less than 2 to the k plus 1. Is that right? Yes, that's what we need to show. Okay, so what we're going to do is this. We're going to multiply. Here we go. So let's start with this. We're going to multiply both sides of this by 2. So here I get 2k is less than 2k plus 1. Is that right? Okay, so you see how, like, whenever we're dealing with exponents, you multiply by the base? Okay. So now let's go to this. We said k is greater than 1, right? If k is greater than 1, which means k minus 1 has to be greater than 0, right? Okay. Now, okay, so this is a k, but can we write 2k as 2k minus k? Can we write k as 2k minus k? Why not? It's free. It doesn't cost us anything. So here I get 2k minus k minus 1 greater than 0. 2k minus, stay with me here, I know you have no idea what I'm doing, k plus 1 greater than 0. Okay? Now, what's 2k then? Is 2k greater than k plus 1? Can we say that? Okay, now, can I just flip the positions of those and say k plus 1 is less than 2k? Can I do that? I can do that, right? I just read it from backwards. So now take a look at what we have. I have this and I have this. Let's just write them together here. But I'm going to write the second one first. So what I have here is k plus 1 is less than 2k, and 2k is less than 2 to the k plus 1. Let's reason this out. If I have a number less than x, and I know that x is less than the other number, what do I know about these two?
K plus 1 is less than...
K plus 1 is less than 2 to the k plus 1. So take a look. Take a look. If 6 is less, okay, sorry, let's do it this way. If x is less than 6, and I know 6 is less than y, what do I know about x and y? X is less than y. So from here, this is called the transitive property of inequality. So k plus 1 is less than this. K plus 1 less than 2 to the k plus 1. All right? So again, QED. Okay? All right, so what we need to prove here is 2n is less than 3 to the n for all integers. So let's just try it for n equals 1, see if it works. 2 times 1, is it less than 3 to the 1? Yes, it is. Fabulous. Woohoo. Okay? So, n equals k, step, 2k is less than 3 to the k if k is less than 1. No, if k is greater than 1. Okay. So now for the n equals k plus 1 step, okay, so we need to start with this and then massage this to get k plus 1, right? So I need, okay, so what is it that we need to show?
K plus 1.
I need to show that 2 times k plus 1 is less than 3 to the k plus 1. So basically just that, right, with a k plus 1. So that means I need 3 to the k plus 1. Well, I have 3 to the k. Let's multiply by 3, and I'll get 3 to the k plus 1. Okay? So now I have 6k is less than 3 to the k plus 1. So look, I already have this part. You see that? Now I need 2k plus 1 to be less than something which is less than 3 to the k plus 1. Okay, I need to, right? Okay, so I actually like, oh my god, okay, so I actually like this problem. Okay, so we said all this happens if k is greater than 1, which also means k minus 1 is greater than 0. Okay, so now check out what I need here. What I need is to end up with something times k plus 1. Okay? Something that's factorable, k plus 1. All right? So what do you suppose we do? Okay, so if I wrote this as, I'm gonna do trial and error. 2k minus k. Then I get 2k minus k minus 1. Let's see if this is going to work. Is that going to work?
No.
Why not? Well, it might work.
That's what I like. 3.
Oh, here's why it doesn't work. I need to have 2k plus 1. right? But I don't have a 2 here, so I need a 2 here. That means instead of 2k minus k, I need to do something minus 2k. Why don't I just do 4k minus 2k?
Yeah, where do you get the k minus 1 is greater than 0?
Because all this happens if k is greater than 1, right? And if I bring the 1 over, okay, so why don't I do 4k minus k? Minus 2k. So now I have 4k minus 2k minus 1 is greater than 0.
Wouldn't that give you an extra k?
Yeah, that would be 2k1.
Yeah, wouldn't it? Yeah, 2k minus 1.
And it would be,
So when you have to do 4k minus 3 again? Yeah.
oh no, 4K minus 2.
Except if we do it this way,
6k.
Oh, yeah, 2k minus 2.
why don't we write this as 2k minus 2 is greater than 0? I can totally do that.
Okay.
And then 4k minus 2k minus 2 greater than 0. So 4k minus 2k plus 1 greater than 0. So 4k greater than 2k plus 1. Reverse it. And we get that. So now, let's write this and this. But second one first. 2k plus 1 less than 4k. 6k less than 3 to the k plus 1. Does that still work?
No,
Why not?
because you don't have the same.
It doesn't matter though, because this is less than 4k,
Or 4k is
and
greater
4k is already less than 6k, which is less than this,
Baby of a friend.
right? So it still works, doesn't it? It still works, doesn't it? Right?
What is the total?
So forget about the k. Let's say this is less than 4, and 6 is less than this. Okay, so this is greater than 6,
6 is greater than
but this is less than 4. Right?
And even,
Is this still greater than 2? You can put in another step in the middle. In the middle, let's say 4k is less than 6k, that connecting step. So now look, this is less than 4k, 4k is less than 6k, so this is still the smallest. 6k is less than this. So in this list, who's the smallest and who's the biggest?
smallest is 2 times
This
k
is the
plus
smallest and this is the biggest, right? If this guy's younger than 4 and this guy's older than 6, clearly that guy's the youngest and that guy's the oldest. Okay? Do it with ages. If you have less than $4, your friend has more than $6, he's got a lot more money than you do. Well, $4 more anyway, at least, right? So we can say, therefore, 2k plus 1 is less than 3 to the k plus 1, and there we have it.
We have to include the therefore.
Huh?
When we answer, do we have to include the therefore?
You don't have to, but it's nice. And this will be, do not Thursday. Okay, so